Hi you guys, in today's video I wanted to cover how to reduce fractions and how to convert in between forms between improper numbers and mixed numbers. So on the left I've started with mixed numbers and we're going to convert them to improper and then we'll convert them back to mixed so you can see how the whole loop kind of goes. So a mixed number is just that, it's a mixed number that has a whole part with a fractional part. So that means you have 4 wholes and then you only have 1 out of 5 of the next thing, whatever it might be. So fractional part. So when you have a mixed number and you need to convert to improper fraction, the process is to multiply your denominator times your whole and then add the numerator. So one more time, denominator times the whole, add the numerator. So whatever your denominator is, right, my denominator in my mixed number is a 5. The denominator in my improper fraction will also be a 5. So 5 times 4 is 20 plus 1 is 21. And then you have 21 out of 5. That's your improper fraction. So let's just do that on these 3 that we can see. So we'll do times and plus here, we'll do times and plus here, and we'll do times and plus here, all to convert from mixed to improper. So again, my original denominator in the mixed number is a 2, so my denominator in the improper fraction will also be a 2, and then from there it's just multiply and add. So 6 times 2 is 12, plus 1 is 13. For 3 and 1, 7, you have 7 as your denominator. So 7 will be your denominator in the new improper fraction. So 7 times 3 is 21, plus 1 more is 22. So 22/7 is your new improper fraction. And then finally, 3 is your original denominator. So 3 will be your denominator in the end. And then all you have to do is do 3 times 5 and get 15, plus 2 more is 17. So 17 over 3. So now we've taken these 4 mixed numbers and we've converted them all to improper fractions. Improper fractions, bigger numbers on top, smaller numbers on bottom. Then now we're going to take these improper fractions, which is something we have to master, and we're going to have to go back to mixed. So in this case, the process is just to divide, right? So 21 divided by 5, that means 5 goes into 21. Some amount of whole times, some amount left over out of some amount that we're taking. So again, this denominator is 5 from the original. So my denominator will be 5 in the final mixed number. Then you got to figure out how many times 5 goes into 21 whole. So 5 goes into 21 4 times without going over. So 4 times 5 is 20, and then we'll have 1 left over. So 4 is your whole. So 4 goes here. And then this is your leftover, this 1. So 21/5 converted back to 4 1/5 as a mixed number because we just divided. So 5 goes into 21 4 whole times with 1 left over out of the 5. And that's the process of converting improper to mixed. So you see we went from 4 1/5 to its improper version, 21/5, and then we took its improper version, 21/5, and we went back to mixed, 4 1/5. So we'll just repeat this process for the rest of these examples. Okay. All right, so 13 over 2, right? We're just dividing. So how many whole times does 2 go into 13? It goes in 6 whole times to get to 12 with 1 left over. So 6 is your whole, 1 is your leftover, and 2 is your original denominator, so it'll be your final denominator. So 6 1/2. And that's what we had here. So we can verify that we're doing everything correctly. Same thing here. 7 goes into 22. We'll do division. 22 3 whole times to get to 21 with 1 left over. So 3 wholes, 1 left over out of 7. 3 and 1/7. And lastly, 17 over 3. We just divide. So 3 goes into 17, 5 whole times to get to 15. And this one will have 2 left over. So we'll have 2 left over. So 5 is the whole part, 2 is the leftover, and 3 is your original denominator. So it'll be your denominator in the end. So 5 2/3. So you can see the relationship between these improper and mixed numbers. So 4 1/5, 21/5, back to 4 1/5. So multiply, add. to get to improper, and for improper, you just divide your way back. How many wholes, how many leftovers, out of how many. Okay, moving on. Reducing fractions. Reducing fractions loses points left and right. So the computer wants you to always reduce the fractions. In general, always reduce your fractions. How do you do that? You find numbers that are in common. So you create a list of all the factors that are in 12. 1 is always in every number, 2 goes into 12 6 times, 3 goes into 12 4 times, 5 doesn't, 6 does, it's a repeat, and then you have 12, right? So these are all the factors that are in 12. Then you also have a list of factors in 30. So 3 times 10, 2 times 15, 5 times 6, and then 1 times 30. And out of all these numbers, you pick the one that they both have in common. So an option is 2, an option is 3, an option is 6, and the only other option I see, that's it. So out of all those options, you want to try to pick the biggest. So 6 looks like it's going to be the winner. So 12 out of 30, if we reduce it by 6, that means divide everything by 6. You'll have 2 over 5 in the final, and then that will be your reduced fraction. So it's important to know your multiplication facts. That way you'll be able to find out numbers that reduce. Just know all your even numbers, any number ending in 0, 2, 4, 6, or 8 is divisible by 2. Also, numbers ending in 0 and 5, those are divisible by 5. And the most obvious out of all of them, if it ends in a 0, then for sure it's divisible by 10. So here's just a few divisibility rules. There are more divisibility rules if you want to look them up, that you can determine whether numbers are divisible by other numbers. But for these purposes, this is just general rule. Okay, developmental. You want to recognize, are these numbers I'm dealing with even? Do they end in 0, 2, 4, 6, or 8? If yes, then you know you can divide by 2. I also know that 6 goes into 12, so I can divide this by 6. I always want the biggest number to come out. That way I have less work, less steps. 20 and 60, that number is divisible by 10. So if I divide out 10 from each of these numbers, then I'll have 2 over 6, and then I can still keep going, right? So if you reduce and you don't get to the final answer, then you can always keep going until you can't divide anything else out. So I can also slash the zeros in order to cancel out that 10 as well. So 2, 6. Now I'm back to evens. I can divide this one more time, and then I'll end up with the simplest form, 1 over 3. 21 and 28, they share a 7. So if we divide a 7 out of both the top and the bottom, you'll have 3 over 4 in the last step, reduced. So 21 over 8 will get marked wrong, but 3/4 will get marked correct. And it's the same value, just represented differently. So you always have to reduce, you always have to reduce, you always have to reduce. 24 and 48. The first number that comes to mind is the 2. So I'm just going to start with the 2 and work my way down. So this will be 12, and this will be 24. Then if I divide by a 3, they both share a 3. I'll get 4 over 8. And then finally, I can reduce by 4 and get myself 1/2. So in any of these steps, I could have just recognized 24 was half of 48, and I could have went right here to the final answer, 1/2. But I'm just trying to show you that it doesn't matter. As long as you start somewhere, you can work your way to the bottom. The simplest form, 1 over 2. And the last one, 50 over 10, they share a 10. So if we divide by 10 and we divide by 10, then we'll have 5 over 1. So 5 over 1 is the same as just 5. So however you want to represent it, it's the same. There's a 1 under everything. So always reduce your fractions and simplify when anything is divisible by, when you have a number ending in 0, 2, 4, 6, or 8, it's always divisible by 2. 0 and 5, you can always divide out 5. And then if it ends in a 0, then for sure it's divisible by 10, 5, and 2. So hopefully this helps. Have a good day. Thanks for watching.